Hello. Welcome to GPS Manipur. This is my fourth attempt in making. No, it's third attempt. One attempt was just short. Third attempt in making this video on this chapter number 6, motion. In beginning, I tried only recording my screen, not my face. Okay, and I thought, okay, let me start putting my face. And second, when I started recording my face, the face was not that clear enough because light issue was there. Okay, and in third attempt what I did was I was making the video. Everything was done. It took around 1 hour 50 minutes around, where I've recorded nearly all the topics. Some topics were left. Then I came to realize that okay, it was not recorded the screen was not recorded. Then I stopped there, and now I'm giving it another attempt again. Okay, I hope this will be successful. If it is successful, you will be watching me. Okay, if you are watching me and listening to me, then I hope it will be a successful one making this video. Let's start. It is chapter number 6, motion. Sir, what is motion? Simple. Let's start. When do we say something is in motion, or do you know motion exactly? Motion is when something is changing its position with respect to time. I'll explain it. Let's go. If you look outside, you'll see birds flying. Is it motion? Yes, it is motion because birds is flying. Sir, what about car is running? Yes, motion. Sir, what about my blood is moving? What is that? Sir, that is also motion. Yes, cars moving, fish is swimming, birds are flying, blood flowing, all these are motion. So what else? Even planets are revolving around the sun, right? That is motion. So stars, right, in the sky, you'll see, okay, stars are not moving. Actually, they are moving. Nothing is stationary. They are moving. Okay, so that is also motion. Atoms, in the atoms, electrons are moving around. You know all these things, right? Nucleus will be there. Electrons are revolving around the nucleus, right? All these are motion. So what else? All these things are called motion. Okay, if you move from one place to another, then we call it motion. When do you say? How do you know something is having motion? Interesting question. This question sometimes teacher used to ask in a class. When do you say an object is in motion? An object is in motion when its position changes with time. Sir, we didn't understand. When its position changes with time, what does it mean? I'll explain it to you. Let's say you are here. You see someone standing here. And after some time, after 2-3 minutes, look, this person has reached in the second place. Okay, now that person is having motion, right? Because it has changed its position with respect to time. With time, this has changed. This is called motion. You see a car. Okay, if car is moving, now it will be somewhere here. And after some time, it will move and go to another place, right? So car is also having motion. Okay, so you say object is in motion when its position changes with time. Okay, is it clear? Let's go next. Next is rest and motion are relative. Rest and motion are relative. Very interesting concept. I like this. Okay, actually this came into phenomena, into idea because of Albert Einstein. If you have heard about the person, if not, don't worry. Okay, anyway, you will understand the concept. What is it? It is that, let's say, sometimes you have observed this. You are sitting in a bus, and when you are sitting in a bus, you look outside, then you'll see the trees are going backward. Okay, if you are in a bus and this bus is going this direction, then there will be trees outside, right? There will be trees, lots of trees outside. Then you'll see these trees are going backward. Okay, now question is, are the trees moving? Sir, no, trees are at rest, they don't move. Then who is moving? Sir, I'm sitting in a bus, I'm moving. But for you, the trees are moving. Okay, for you, trees are moving. Sir, let's make it more interesting. Let's say one boy is there, this boy. Okay, and you are sitting here, and there is driver here. This is driver, bus driver. This is you. This is your friend. Okay, and these are trees. Okay, now according to your friend and trees, according to your friends is standing here and trees are there. According to your friends, are the trees moving? No. Why? Because the friend is also here, trees is also here, they are not moving. Okay, okay. According to you, is the driver moving? According to you, driver moving or not? No. Why? Because you are here, driver is here, driver doesn't change its position, right? You see, okay, you started walking, you started sitting, you sat in the bus in Imphal, let's say, and let's say you have to go to Ukhrul, let's say. Okay, from Imphal to Ukhrul you have to go. Now you have sat here and bus driver is here, and from Imphal you started going, you reach Ukhrul. From Imphal you reach Ukhrul. After you reach Ukhrul, you see, okay, you are sitting here, bus driver is here. According to you, with respect to you, driver is moving or not? No, it is sitting there, you are also sitting here. Okay, let's go another step now. According you are here, your friend is here. According to your friend, you are moving or not? Sir, yes. According to your friend, driver is moving or not? Yes. Why? Because your friend is here, bus it will go away, right? So according to your friend, bus is also moving, inside the person you are also moving, but driver is also moving, all are going together with bus, right? You are in motion. Are you getting the point? Now according to you, you are sitting in a bus. When you're looking out of window, then you'll see that your friend is going backward, tree is also going backward, you'll see like that, right? So now comes the interesting thing. So all these things, according to your friend, you are also moving, driver is also moving. But according to you, driver is not moving. According to your friend, driver is moving. So motion depends upon the person who is looking. If you are looking, driver is not moving. If your friend is looking, driver is moving. So it depends upon the person who is looking. Okay, this is called relative. Okay, let us understand some. An object may appear moving to one person and stationary. Stationary means not moving. Stationary meaning is not moving. Okay, to another. Example, trees appears to move backward when you are in a moving bus. If you are sitting in a moving bus, trees are going backward, backside, right? You're going like this, trees will go backside. Trees are moving? No, you are moving. But according to you, trees seems moving. Third, a person on a roadside sees the bus moving, but trees are at rest. Now this person, your friend, sees trees are at rest, but you are moving. Okay, motion is relative, meaning motion is relative. Why relative? It depends upon the frame of reference frame. What does this mean? Frame of reference. Okay, what does this frame of reference means? Is called origin, or we can say starting point, or we can say from where you are measuring motion. You are measuring motion. Okay, from where you are measuring motion. Are you getting my point? Let's go next. So in order to describe any motion, how can you, okay, now we have understood. What do you understand? We know what is motion. If anything is changing with respect to time, if anything is changing its position, that is called motion. What do you understand next? Next we understand something about what is that? Relative. Motion are relative. Okay, we're going to understand the third thing. Third thing is how to describe motion. How can we tell something is moving? Describing the motion. So for that, first we need to understand reference point. Reference point is from where you are measuring. Okay, from where you are measuring the motion. So to describe the position of an object, we need to specify a reference point called origin. Okay, let's take an example. Interesting example. Let's say school is 3 kilometers north of your house. So you have your house. This is your house. Okay, I'm very bad painter, very bad artist. Okay, anyway, I hope you can see this. Now you have your house here. So example, you have your house here, and let's say you have a school. Sir, school, where is school? School is north. This is east. This is east side, west side, north side, south side. So your school is to the north. Okay, your school is to the north. Let me say this is your school. Okay, this is very bad artist. Anyway, this is your school. Now what is, now you want to say, okay, distance from your school to your house, it is 3 kilometers. Okay, now when I say, I happen to ask, uh, how long, where is your school? I ask you, sir, hello, Mr. Tomba, or hello, Mr. Ajit, or I happen to ask you, okay, where is your house, or where is your school? Then you'll say, sir, it is 3 kilometers to the north from my house. Okay, so you said it is 3 kilometers to the north from my house. From where? From your house. From house you are measuring, right? So your house is called reference point. Okay, distance is 3 kilometers, direction is north. Let's say I happen to, you are in school. Let's change the question. Let's say you are in school, and in school I said, okay, where is your house? Then you'll say, sir, it is 3 kilometers, it is 3 kilometers to the south. It is 3 kilometers to the south. Sir, from school to house. I ask you where is house, and you'll say, sir, it is 3 kilometers to the south. Very good. Then where is the, what is the reference here? Reference is your school. Reference is your school. From school you are measuring the distance. Okay, I hope you understood the reference point. Okay, from where you are measuring. If I ask you in school, you say, okay, sir, from my house is, from school you are measuring. From house, you are measuring from house, so house is your reference point. Let's go next. Next is motion along a straight line. Let's understand this. Let's say you are here, and you started moving and you reached here. So from O you reach X. What is the distance? Distance is 6 kilometers. So I asked you, what is distance traveled by you? Distance is equal to 6 kilometers, sir. Let's say you started from here 6 kilometers. Again you went till Y. So from X to Y, 6, from 6, 7, 8, 9, 3 kilometers. So how much distance is that? Sir, distance is 6 plus 3 kilometers, which is 9 kilometers. Let's say more, let's discuss more. Let's say from Y, let's say you reach till Z. You're going in straight line, okay? You reach till Z. And from Y to Z, it is 3 kilometers more. And I ask you, what is your distance? You'll say, sir, 3 kilometers plus more. So 9 plus 3 is, sir, 12 kilometers. Now let's say from Z you came back to Y. Okay, from Z you came back to Y. Sir, what is the distance? Sir, from Z I came back to Y, again I travel 3 kilometers. So it will be plus 3, it is 15 kilometers. Are you getting my point? This is distance. Now there is another thing called displacement. There is another very interesting thing called displacement. Okay, what is distance? Distance is total length of path covered. Okay, what is the total distance? What is the total length you have covered? That is called distance. Now what is displacement? Displacement is the shortest distance between initial and final position. Displacement is shortest distance between initial and final position. Sir, we didn't get this. I'll tell you what is this. Initial and final position. Let me show you the definition. Shortest distance from initial to final position. What is initial? Initial is beginning position, beginning or starting or reference, we can call many name. Okay, reference point. Final position, it is the final position. Final position, what shall I say? Final, the position where you stop. Okay, position where you stop. Position where you stop. Stop having motion. Stop having motion. Okay, now from 0 to x, final position is 6 kilometer. I'll tell you what is this. Let's say now you happen to walk more and reach till x. Okay, now first you happen to walk till x. What is the distance? Sir, distance you do plus 6 plus 3 again. It will be 15 plus 3, 18 kilometer. Now what is displacement? Displacement is about initially you are here. Initially you are here, beginning you are here, finally you have reached here. What is the distance between these two? Sir, only 6. So displacement is only 6. Sir, what about, let's say I happen to travel from here, I reach till here, y. What is distance? Sir, from 0 to from O to y, it is 9 kilometer. So distance is 9 kilometer. So what about displacement? Displacement also, initially you are here, finally you are here. What is the displacement? Sir, it is also 9 kilometer. Sir, let's go more. Let's say from O to Z, let's say you traveled. Okay, so what is the distance? Sir, from 1, 2, 3, 4, 5, 6, 7, and 9, 10, 11, 12. So from till here, 12 kilometer. What is the displacement? Initial position, final position, displacement is also 12 kilometer. Is it right? Let's go more. Let's say, sir, let's go till Z and let us come back to Y. So what will be the distance? Distance will be 12 plus 3, 15 distance. What about displacement? Displacement means initially you are here and finally you are here. So what is the displacement? So displacement means only this one. How much? 9 kilometer. I hope you are getting the point. So let's say you are moving from here O, reach X, Y, Z and came back to X again. What is the displacement? Displacement is 6 kilometer. Distance, sir, 12 plus 6, 18. Distance is 18 kilometer. Let's say you go from here to here, only this one. What is the distance? Distance is 6 kilometer. What is displacement? Displacement is also 6 kilometer. For displacement, only initial and final position matters. For distance, you have to count everything. I hope you understand. Okay, now there is one more thing, something called scalar quantity, and there is something called vector quantity. Okay, scalar and vector. Scalar and versus vector. Scalar means only number, only magnitude. Only magnitude means what is your weight? How much kg are you? Sir, 5 kg. No. Sir, 45 kg. That is your weight. That is scalar quantity. Vector quantity. What is vector quantity? Vector quantity is like I'll ask you, where is your house? Also you'll say, sir, 20 kilometer to the east. Then you say, okay, 20 kilometer plus direction. Which direction also you said, na? Like let's say, where is your house? And you'll say, sir, it's in 20 kilometer from Imphal, 20 kilometer south from Imphal. Okay, so you said distance as well. And you said the direction also. So it is magnitude as well as direction. Okay, so distance is a scalar quantity. Why scalar? Because distance, if you travel anywhere, okay, it is just a number. You can just calculate a number. What about displacement? Displacement is you have to have the direction. Why? Because if you change the direction, displacement changes. Okay, it is not the sum anymore. It can become minus also. Okay, so can distance, if you start traveling, distance is always positive, but displacement can be positive also. Positive means if you start traveling from here, if you go this side and let's say you came back this side, back side, then what is the displacement? Negative side, sir. If you travel like this and let's say you stop here, What is the displacement? Sir, positive. Let's say you went backside. What is the displacement? Sir, from here, negative. Or let's say you travel, you started traveling like this direction, and you came back and stop here in the same position. So what is the displacement? Zero. So displacement can be positive, negative, or zero. There is a question. Question, try to answer. Question in your textbook. Question says, there are some good questions. So let us discuss that. In what direct condition is the distance covered equal to the magnitude of displacement? Can distance and displacement be equal? We have discussed already, right? Can distance and displacement be equal? Yes. Sir, if I travel from here till x, so what is the distance? The distance is 6 kilometer. Sir, what is the displacement? This is initial position, this is final position. The displacement is also 6 kilometer. So can distance and displacement be equal? Yes. When? If they travel in a straight line and does not change the direction. Let's say you go straight line but came back. What is the distance? Sir, 9 plus 3, 12. And what about displacement? So only this one. So distance is this one, displacement is only this one. So they are different. Okay, so distance and displacement can be equal. When they can be equal? If they travel in a straight line, okay, in a single direction without changing its path. Straight line in one direction. Okay, distance covered is equal to the magnitude of displacement. Second, can the distance traveled by an object be smaller than the magnitude of displacement? Can a distance be smaller than the displacement? Never. Let's say you started traveling, you reach here. Let's say you travel 6 kilometer. Sir, distance also, displacement also equal. Let's say you came back 3 kilometer. Came back 3 kilometers. So what is the distance? Distance is 6. Again 3. 6 plus 3, 9 kilometer distance. Sir, displacement. Sir, displacement is only 3 kilometer. So distance can be more or distance can be equal to displacement, but distance can never be less than displacement. Are you getting my point? I hope I'm not just shouting. Okay. So no, the distance traveled by an object is always greater than or equal to the magnitude of displacement. It can never be smaller. It is always greater than or equal to, will never be smaller. I hope you are getting my point. Next, an object covers a distance. There is an object, it covers certain distance. Can it have zero displacement? Can an object have zero displacement? Yes or no? Yes. Why? When? Let's say you started traveling from here and came back to the same position. Let's say you started traveling from Imphal to Ukhrul, or go to Chirachandpur, or go to Thawabal, wherever you want to go, you go. Okay? You go and come back to the same position again in your house. Morning you went and evening you are at your house. Now what is the total displacement? So zero. Why? Because the morning also you are there, evening also you are there. Same position. Initial and final position are same, right? Initial means starting from Imphal. What is the ending point? Final position. Sir, Imphal, my house. That means same, right? So displacement is zero. What about distance? Sir, distance is, I went to Ukhrul. Ukhrul is, let's say, 50 kilometer, 80 kilometer. I don't know. I think 80 kilometer. I don't know. 80 kilometer. Sir, Ukhrul 80 and coming back also 80. 80 plus 80, 160 kilometer. Today I traveled 180 kilometer distance. Sir, what is displacement? Zero. Why? Sir, morning also me here, evening also me here. Then this displacement is zero. Are you getting my point? Can displacement be zero? Yes. An object can have zero displacement even after covering some distance. For example, if a person walks 10 meters forward and 10 meters back to the starting point, the total distance covered is 20 meters, but the displacement is zero. Are you getting my point? Displacement will be zero. Given the example here. Okay. The last question for this, state true or false. Displacement cannot be zero. Why? Displacement can be zero. It can be negative also. So this is wrong. False. Second one, magnitude of displacement may be equal to the distance covered. Displacement can be equal to distance covered. Yes or no? Yes or no? Yes. When? If they travel in a straight line. So yes, true. What about this one? Magnitude of displacement is greater than distance covered. Can displacement be greater than distance? Never. I hope you're getting my point. Let's go next. What have we discussed so far? We have discussed in the beginning, we said when we do we say an object is having motion, first thing. Second thing, we talk about a reference point. A reference point means from where you are measuring. Let's say you are going from Imphal to Ukhrul and you said I traveled 80 kilometer distance. What is the starting point? Imphal, right? That is your reference point. What is the final position? Ukhrul. Okay. And after that, we have discussed about distance and displacement. Now we are going to discuss about uniform and non-uniform motion. This is another interesting concept. Let's go. Uniform motion. When do you say, what do you mean by uniform motion? An object covers equal distance in equal interval of time. This is called uniform motion. An object covers equal distance in equal interval of time. An object covers equal distance in equal interval of time. This is called uniform motion. Let us understand. In this, there are two things. One is equal distance and another is equal interval of time. Okay, equal distance, equal interval of time. Let's say you are going from your house to school. This is your house. From house you are going to school. Okay, now let's say from school, house to your school, it's not that far. Let's say it is just 30 meter. Okay, now it is 30 meter. Now you are you when playing slowly, or let's say it is 300 meter. Okay, now you started walking from your house, and let's say, let's break it down. This is 30 meter, 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 3 4 5 6 7 8, 30 meter, and this is 30 meter. You started walking from your house, and let's say it is 300 meter. You are here in your house and you are going to school. Now what do? You travel this 30 meter from your house. This is from here to here. Let's say this is 30 meter in 1 minute. In another minute, you travel from this to here another minute. From here to here another minute. Let's say this is 2 3 minutes. In 4 minutes you reach here. 5 minutes you reach here. 6 minutes you reach here. 7 minutes you reach here. 8 minutes you reach here. 9 minutes you reach here. And 10 minutes you reach here, school. Okay, so what is happening here? You are traveling 30 meter in 1 minute. Every 30 meter you are traveling, you are taking 1 minute for every 30 meter, going at the same speed. This is called uniform motion. Let's go next. What is non-uniform motion? In equal and unequal distance in equal interval of time. Let's say you are here. This is your house. You have to go to school, and now same 300 meter, 1 2 3 4 5 6 7 8 9 10. You started walking from your house and you want to reach to your school. Now you take from here to here 1 minute. Okay, but in another minute you travel from here to here. Okay, again you took this from here to here, you took another minute. Again you came back and you took 1 minute here. Okay, are you getting my point? You are taking 1 minute, at this is 1 minute, 2 minute, 3 minute, 4 minute, and in 5th minute you take only half, and in 6th minute you covered here. Now what is happening is, you are traveling, sometimes you are running, sometimes you are going slowly. This is called non-uniform motion. Look, a object covers unequal distance are unequal in equal interval time. Let's say in 1 minute, sometimes you are taking more and you are taking less. Time is same, but distance are different. So unequal distance in equal interval of time. Are you getting my point? Let's go next. So example is, you are driving a car. You are driving a car from a home and you started going. Sometime the breaker will come. Sometime like mud will be piling up. Sometimes, sir, the road is very bad. Sometime you will see and a truck is coming, so you have to drive slowly. Sir, sometime beautiful girl coming and going away, and you are driving bike and the girl is going in scooty. Sir, that girl very fast going, then I have to also go, no, so off then needed, no. So you went. Are you getting my point? and suddenly you see police uncle, then you have to drive slowly. Okay, so sometimes you are increasing the speed, sometimes you are decreasing the speed. Speed is changing all the time. Okay, so if speed is changing all the time, then we call it as non-uniform motion. There is one question that is usually asked in the exam. Teacher love asking this question, so I made it as an answer. Difference between uniform motion and non-uniform motion. What is the difference? Uniform motion, object covers equal distance in equal interval of time. They cover equal distance in equal time. Non-uniform motion, unequal distance in equal interval of time. You keep time as equal. Okay, distance are not equal. Keep this in mind. Okay, I can explain this more detail. Don't worry, I'll make short clips like that and explain all this concept. Okay, if you love physics, or if you are just to complete the syllabus, then okay, this much is okay. You just remember this is unequal distance, time is equal, same. The definition in this both are, one is equal distance, another is unequal distance. You'll remember both. Second, speed is constant, meaning same speed. Here speed keeps changing, sir, bike and scooty wala. So speed keeps changing. Third, acceleration, no acceleration is involved, meaning same speed. You are not pressing, you are not doing an aram, so you're going in same speed. No, you are not increasing the acceleration. I'll explain you. Okay, but acceleration means accelerator, vehicle one. Seller, you call seller also accelerator. Okay, that is not there. No acceleration. Here acceleration is there. There may be, you may increase the speed or you may decrease the speed, so acceleration is there. Example, a car moving at a constant speed, same speed on a straight road, a car moving through traffic with varying speed. Okay, next, I hope you understood whatever we discussed so far. First we discuss when do you say object is in motion, what are the motion. Second, we discuss about reference point, starting point from where we are going to measure. We also discuss about relative motion, the trees, you, driver and all. Okay, after that what we have discussed, we have discussed about distance and displacement, and we have also discussed just now about motion, uniform and non-uniform motion. Now we are discussing about speed and velocity. Sir, what is speed and what is velocity? Let's discuss. Now speed is, distance, right? Speed is nothing but distance divided by time. Distance covered per unit time. Per unit time means distance by time. Okay, speed is equal to distance by time. We used to write v is equal to x by t. Okay, or x is distance, v is speed here. Okay, now this is one thing. So what is velocity? Velocity is displacement by time. Speed is distance by time, velocity is displacement by time. 1 point. Can you understand? Displacement per unit time, distance per unit time. Distance per unit time is speed, displacement per unit time is velocity. One thing is clear. Let me make you clear another thing. Formula: speed is equal to distance by time, velocity is equal to displacement by time. Second thing. Third thing, understand this. Third thing. What is third thing, sir? I will explain it to you. Distance is a scalar quantity. I told you, distance is a scalar. Scalar means only number having one, only magnitude. We don't care about direction. What distance did you travel today? 80 kilometer. Done. I don't want to know where did you go. So displacement, sir, 80 kilometer to the south, 80 kilometer to the jungle, 20 kilometer to the river. Direction is there. So this distance is scalar, displacement is vector. So scalar divided by time. So speed is a scalar quantity. Scalar quantity. Why scalar? Because the distance is scalar. What about velocity? Velocity is vector quantity. Why vector? Because displacement is vector. Can you remember the third point? Let's go with the fourth point. Sir, fourth point is SI unit. Sir, what is SI unit? Let's say, if I say distance, I have to say 20 kilometer, 30 kilometer or 20 meter. So kilometer, meter, these are called units. Okay. Or if you say, sir, what is your weight? 50 kg. kg is unit. Okay, 50 kg, kg is unit. Sir, what time you used to wake up? 5 a.m. am is unit. Okay, sir, how long did you study? 4 hour. Hour is unit. Okay, so these are units. So what is the unit for speed? Speed unit is meter per second, kilometer per hour, okay, centimeter per second. You can write down anything. Okay, sir, from where getting? Sir, distance one is, what is the SI unit of distance? Distance SI unit is meter. Time, second. So can I write down meter divided by second, or we equally say meter per second? From where? From formula. If you know the formula, you can remember this also. Okay, now I'm telling you the trick to remember also. Okay, so velocity is displacement by time. So displacement, meter by second, kilometer by second, hour, second, anything. These are called units. There is something called SI unit. SI unit means everyone will follow. Okay, if I say SI unit of speed is, I'll say meter per second. So this one I'll take and I'll go on everywhere. Sir, meter per second is the SI unit. Okay, SI unit means it's fixed. It will be done by everyone. Everyone is going to use this. So SI unit is meter per second. It's international standard units. SI is international standard unit. Okay, so it is for international. Everyone is going to use. So meter per second, we're going to choose one. We can take kilometer per hour, centimeter per, these are all units, but for us we'll take meter per second as the SI unit, international unit. Everyone will use this. Okay, getting the point? So are you clear with this? Let's go one more concept. There is a very interesting concept about average speed. What is average speed? Let's say you started traveling from Imphal, and this time where shall we go? Let's say I want to go to Assam, let's say. Okay, and no, let's not go too far. Let's say from Imphal to Sekmai. You started driving and you reach Mantripukri and Chingmairong. Okay, after that you came more and you reach Fightinga, and after that you reach Sekmai. Okay, so traveling like this. Now what is happening exactly here? Sometimes you are increasing the speed, sometimes you are decreasing the speed. It's not that you are going at the same speed, right? Imphal, it is traffic is heavy, so you have to drive slowly. And Fightinga till Fightinga, I think road is good. So after that road is not that good again, and after that road is good again. So sometimes your speed will be high, sometimes speed will be low. So what is your speed? If I ask you, so what is your speed? What speed did you travel to Sekmai? So you'll say, sir, speed then not fixed. Sometimes then 80 also going, sometimes then 20, and what to do? Sometimes then very slow, 10 kilometer per hour only. Then, sir, okay, let me tell you, in vehicle front, okay, in vehicle front there is speed given, okay. In vehicle, there is something called speedometer. We call it as speedometer. It is given there, okay. So sometimes speed is high, sometimes speed is low. Now, for this, if I ask you what is your speed, you cannot say, right? So for that, there is a term called average speed. How to find out? It's like, what is the distance from Imphal to Sekmai? I'll ask you first question, and you'll say, sir, 40 kilometer. It's too much. 20 kilometer. Okay, fine. 20 kilometer. Sir, 20 kilometer. And how long did you take? How much time did you take? Sir, 20 kilometer in 1 hour. I took 1 hour to reach this 20 kilometer. So what is your speed? 20 kilometer per hour. That is your average speed. Why average speed? Sometimes then high, sometimes low. No, it is not the speed at the particular time. Let's say, sir, in Fightinga then 40 kilometer per hour, but when I came out from Imphal, it was only 10 kilometer per hour. Speed was different, right? So we are going to find out the average one. How to find out the average? Find out the total divided by total time. I have understood this. I hope I am able to make you understand. If not, please write down in the comment below. I'll explain you. Don't worry. Let's go next. Average velocity. What is average velocity? Average velocity is very interesting one. Average velocity is same thing. Total displacement divided by time. Actually, total displacement by time. But there is another way to find out average velocity. There is another way to find out. One is total displacement by time. It's not written here. Another way is, let's say sometime you are having good speed. Okay, let me discuss this later on. I'll explain it to you little bit later on. Okay, now you'll not be able to connect. So let's go here. Speed is a scalar quantity. Speed, why speed is scalar? Let me ask you, why speed is scalar? Sir, speed formula is distance by time. Distance is scalar, so speed is scalar. Finish. Sir, velocity vector or scalar? Velocity is vector. Why? Because velocity is equal to displacement by time, and displacement is sir vector, so velocity also a vector. So velocity can change by changing speed, direction, or both. Sir, velocity is if change the speed, if change the direction, so velocity also changes. Okay, this is not a big deal. Let's discuss about this one. Difference between speed and velocity. They'll ask teacher love this question in exam. Okay, it's very easy, but they love to ask this. What is speed? Speed is a scalar quantity. What is velocity? Velocity is a vector quantity. I've explained 10 times why it is scalar and vector. Speed, scalar quantity meaning only magnitude. Magnitude means only number, like kg, 20 kg, 30 kg. No direction. I don't care about, sir, 20 kilometer to south, 20 kilometer east. And I don't care. East, west, north, south. I don't care. I don't care about direction, sir. 20 kilometer from my house to school. I don't care about school or not also. I just care about how much kilometer. That is distance. And if direction is there, that is called magnitude, and direction, that is velocity, vector quantity. Speed cannot be 0 or negative. Speed cannot be 0 or negative. Okay. Sir, why 0 or negative? Speed cannot. Sir, speed is distance by time. Distance can be 0? No. So speed will be 0? No. Sir, distance can be negative? No. So speed is distance by time. Speed will be? No. Velocity can be negative? Yes. Why? Displacement can be negative. Velocity can be 0. Why? Velocity can be 0. Why? Velocity is equal to displacement by time. Displacement can be negative, right? Displacement can be negative, right? So velocity will be negative. Okay. So speed doesn't care about direction of motion. Velocity tells the direction of motion. Okay. Let's go next. Now we are here with acceleration. Sir, what is acceleration now? Explain acceleration. Accelerator, vehicle accelerator. If you are changing your speed, not changing distance. Distance changing, if changing distance means that is velocity, right? Sir, if you are changing velocity, I'll tell you. Let's say you are at your home, not changing anything. You are having motion? No. You started going out of your house. You want to go to school. You started moving. Okay, you are moving. You are changing your position. Are you having some distance? Yes. Now you are changing your position divided by time. Position, distance, distance divided by time. Are you having velocity, speed? Yes. Sir, there is some speed, right? You may be walking slow or fast, but there is speed. Acceleration. Now let's say you are walking with a speed. You are taking out, let's say you are going by scooty to your school, and you are driving at 30 kilometer per hour. Okay. Are you having acceleration? No. Same speed, right? Not acceleration. Now you press the accelerator, speed changes. 30 to 40. Speed is increasing, right? That is called acceleration. Acceleration is change in speed, change in velocity. Are you getting my point? Are you getting my point? So acceleration means change in velocity. Or you call it rate of change of velocity. Or you call velocity divided by time. So change in velocity by time taken. It's change in velocity divided by time. Got my point? Let's say you are driving at 30 kilometer per hour. Okay, suddenly you see a girl scooty coming and you going away. Then you'll say, oh, this girl then going, I have to chase her. Then you increase your speed. Now your 30 kilometer becomes 90 kilometer per hour. Okay, now from 30 to 90, it's not that you just press and direct 90. It will go from 30, 40, 30, 35, 40, 45, 50, 55, 60, 65, 70, like this, right? You have to change the gear also, and speed will change, right? Now from 30 to 90, you reach this speed in, let's say it took 1 minute, or let's say 60 seconds. In 60 seconds you reach this speed. from 30 kilometer per hour to 90 kilometer per hour, it took 60 seconds. Okay, so what is your acceleration? Now you are pressing, you are increasing your speed, acceleration is there, right? Acceleration is equal to 90 minus 30 divided by 60. 90 minus 30 is 90 minus 30 is 60 divided by 60. Sir, 1 meter per second. Sir, how meter per second square? Are you getting my point? Are you getting my point? Okay. Okay. Now let me explain you. If you are changing your speed, you are pressing accelerator. What happens when you press accelerator? It will change your speed. If you are changing your speed or changing, sir, you then telling speed and velocity different in notes in the writing velocity. From now on, I'll use speed and velocity as same thing. I've explained you the difference. Now from now there is nothing called speed. There is everything is velocity. Understand like that. Okay. So I'll use same thing, both as same. Okay. So if you're changing a speed, that is divided by time, that is called acceleration. Now acceleration means, let's say you are traveling now with 30 meter per second speed and you want to reach 90 meter per second speed and you took 60 seconds. Now what is that? 1 meter per second you calculated acceleration. Okay, how did you calculate acceleration? Acceleration is equal to, sir, this final one 90, final means final 90 minus, sir, initial one divided by time. Sir, final is 90, initial is 30, both are meter per second divided by time is how much? 60 second. So 90 minus 30 is 60 meter per second divided by 60 second. 60 divided by 60, 1 meter per second. Sir, downside also second having no. So can I write down like this? Meter per second means meter by second into second. So meter per second square. Second into second is second square, right? So meter per second square. Remember this. We know that velocity is meter per second and acceleration is velocity divided by time. So velocity is meter per second, time is second, so meter divided by second square, or I can write as meter a second. This 2 comes upside, so it will become -2. So I can write a meter per second like this also. Okay, so what did you understand here? We understand this 90 is the final one. Final velocity is called v. From now remember, v is the final velocity. So final velocity minus initial means starting one. Okay, that 30, you are driving at 30 kilometer per hour, right? And you started pressing the accelerator and reach 90. 30 is your initial one, 90 is your final one. How much acceleration you had? Final minus initial, 90 minus 30 divided by how much time you took to reach from 30 to 90. How much? No, the whole time. The time from 30 to 90, how much time it took? It's not that suddenly it will reach, right? So divided by that time, that is called acceleration. I cannot explain better than this. Okay, I hope you got this. If anyone is watching till here, and if you are having any difficulty, want to discuss, then Telegram channel is there. I'll provide the link in the description or somewhere. Okay, so that you can join and ask me there. If you have any question, click the photo and share there. I'll help you because if you want to learn, I'm there to help you. Okay, so let's go. We have discussed acceleration. SI unit of acceleration, sir, SI unit is what? Meter per second square. Meter per second square. Meter per second square. This is meter per second per second, or meter per second square. I can add a meter per second square also. Sir, SI unit, how to find out? You understood, right? So what are the types of acceleration? What are the types? Sir, can there be positive acceleration? Yes, if you are increasing the speed, that is called positive acceleration. Negative, sir, if I reach 90, then I have to stop also. Na? Stopping time, brake will apply. Na? Brake applying, the speed will decrease. Speed, velocity changes, right? Speed changes. Velocity and speed are same thing from now on. Sir, speed and velocity will decrease. No? Then if decreasing means changing, right? Changing also means negative acceleration. Are you getting the point? Negative acceleration will be there. Yes, because if the speed reduces, then it will be, if you apply the brake, deceleration. You call deceleration or negative acceleration. Uniform acceleration. Uniform acceleration is if equal velocity in equal time, equal amount in equal interval. Sir, if I want to go from 30 meter per second to 60 meter per second, then my speed will be, let's say, 2 second, it will be 35 meter per second. Another 2 second, it will be let's say 40 meter per second, 50 meter per second, and another 2 second, it will be 60 meter per second. So equal time, 10 meter per second, 10 meter per second, 10 meter per second, equal time. Time is same, and interval equal amount in equal time, equal amount of what? Equal amount of velocity in equal time. Same, we have been discussing same. Look here, non-uniform acceleration, we have discussed a uniform, non-uniform velocity also. We have discussed about uniform and non-uniform motion also. Same, velocity changes by equal amount in by unequal amount in equal interval of time. Time is equal, but this here, this time velocity is unequal. In that motion, distance was unequal. Equal distance in equal interval time, unequal distance in equal interval of time. Are you getting the point? So equal, unequal, time is same in equal interval of time. Time is always equal interval of time. Is it okay? Let's go next. This question is also very common. Teachers love asking this question also. What is the difference between uniform and non-uniform acceleration? So difference between uniform and non-uniform acceleration are, let's discuss. Acceleration remain constant over time. Acceleration doesn't change. Acceleration remain constant over time. Uniform acceleration, equal acceleration, right? Equal interval of time, so it is changing equally. It's not like a suddenly changing. Equal acceleration. Second, acceleration changes with time. Sir, acceleration remain constant over time. Acceleration changes with time. Sometimes this new high, again slow, again suddenly high, again little high, again break. So these are changing all the time. That is non-uniform acceleration. Velocity, if acceleration is uniform, then velocity will change or not? It will change. If velocity doesn't change, then there will be no acceleration. Speed no increasing, decreasing, then how acceleration? Velocity, speed will change. It will change, but it will change at a constant rate. Velocity changes at a varying rate, at different rate it will change. Sometimes velocity will be high, sometimes suddenly come. I hope you understood. Occur in ideal or control condition. So uniform acceleration, it is very difficult to achieve ideally. Okay, it's very, we can do experimentally, but whenever you are driving vehicle, it will never happen like this. Or if you are walking also, it won't happen like this. Uniform acceleration is very difficult to achieve. Okay, I'll give you an example. Actually, the example for this is, if something is falling. Okay, if something is falling, that is, it will have gravity. I'll discuss this in gravity chapter. Why things fall? Because of gravity, right? Did you hear the story of Newton? Newton was sitting under an apple tree. An apple tree fell down. You know the story. Things comes down. Okay, if this is coming down, that means this is changing is slowly high, right? And it is changing its velocity equally. So this is uniform acceleration. Good example of uniform acceleration. Anything falling down, a freely falling object under gravity. And what about non-uniform? Non-uniform is you are driving a car, or if you are running. Sometimes you are applying brakes, sometimes you are running, and all those things. Fine. Have you understood this? So far, what have we discussed? We started with what exactly is motion, what are different kind of motion. After that, what did we discuss? We discussed about what did we discuss? Relative motion, right? Motion is relative. It depends upon from where you are looking. Reference point. Reference point means starting point from where you are checking. I've given you the example of, you are in a bus and you are sitting, and bus driver is there, and trees are outside, a person is standing outside. All this example. After that, we have discussed about we have followed by motion. No, we have discussed about distance and displacement. Then we discussed about motion, uniform and non-uniform motion. Then we discussed about speed and velocity. Then we have discussed about acceleration, different kind of acceleration, negative, positive acceleration, and uniform and non-uniform acceleration. We have discussed about their SI units. We have discussed vector quantity, scalar quantity. We have discussed quite a lot. Okay, if you are watching till now, okay, most of the students are not here. I think they are not watching till now. Most I am not getting much views also. Okay, so there are only few people watching, and if you are among those people who are watching till now, okay, thank you so much. You'll do great. I'm telling you, you'll do great. Do something meaningful in life. Why? Because you have patience. You have patience to watch. It's already 55-56 minutes. So you have patience to watch 55-56 minutes of video. So it's a very great thing. But I'll not stop here. Sorry to say that. I'll go on. Okay. Maybe it will take another hour. Now we are going to discuss the most complex part, graphical representations of motion. Graphical representation of motion. We are going to discuss this. First, it is distance time graph. What is this? There are two kind of graph we are going to discuss. We are going to discuss a graph. There are two kind of graph. One is distance time graph. Distance time graph, or we called this same thing as distance time graph is also called as position time graph. Position time graph. And another we are going to discuss about velocity time graph. Velocity time graph. Okay, when what we are going to discuss? We are going to discuss under this topic. We are going to discuss for object at rest. We are going to discuss uniform motion. We are going to discuss non-uniform motion. And we are going to discuss about acceleration. Okay, we are going to discuss all these topics and try to draw the graph. First is object at rest. Object at rest means, let's say you are at house, you are at a home, and you are sleeping and you don't wake up. Or let's say you are at a home and you went to your friend house. Your friend house is 20 kilometers from your home. Your friend house is 20 kilometers. So you went 20 kilometers. Let's say this is the distance. Yesterday and today you are in his house. So distance is 20, and in your house you are still sleeping. Okay, you are still sleeping. So from today let us start counting. How much distance have you traveled from your home? Sir, 20 kilometers. Let's say 0 minute. Let's say 10 minutes. You are still sleeping. 20 minutes. You are still sleeping. So you have traveled 20 kilometers and you are still sleeping in your friend house. So how much distance you have traveled? Sir, yesterday I have traveled 20 kilometers and from there I didn't travel anymore. So distance is 20 fixed. You are not moving anywhere. So your position is at rest. You are not moving, right? Distance, you have traveled some distance and after that you are at rest. Now how to draw a graph for that? While drawing a graph, you have to always keep in mind there are two lines. We always used to draw two lines like this. Actually, while drawing a graph, we should draw a big line like this, right? Like this we should draw. X, Y, like this. But now I'm making like this. Let's say this one, this is X, this is Y, this is minus X, and this is minus Y. Now after that what I can do is, look, it is written 1 here, 2 here, 3 here, 4 here, 5 here, and goes on 6, 7, 8. And this side it will be minus 1, minus 2, and minus 3 goes on. And upside I'm making it 10, 20. It's your choice. You can do whatever you want. I'm making it 10, 20 so that I can represent 10, 20, 30 like this. And downside I can go minus 10, minus 20 like this. Okay. Let me make only minus 10. Okay, now let us draw a graph. So when you are at 0, time is 0. How much distance you have traveled? Sir, 20 kilometers. I'm at my friend house today. Then 20 kilometers traveling and I'm at a friend house. Sir, after 1 minute, sir, still in friend house, not moving. 2 minutes, sir, sleeping, how will travel? 3 minutes. After 5 minutes also you are at your friend house, you are not moving. Sir, what if, yeah, I'm at my house and I didn't move? Sir, I'm at rest. Yes, you are at rest. What is the distance? Sir, I didn't move. Distance is 0. If you are at your house, you didn't move, right? Distance is 0. Sir, how will the graph be? Graph will be from here straight. So I cannot show that, right? So I'm making 20 kilometer distance, but after 20 you are rest. Okay, 20 meter, not kilometer. Let me make it meter. Okay, so 20. Now while drawing a graph, this side is time, and time you write down minutes, time is in minutes, and this side is distance is in meter. So you can write down, I can write down kilometer here also. If my distance is in kilometer, I can write down in kilometer. You can make your own example also. Okay, it's not that you have to follow exactly mine. Are you getting my point? So this is, sir, why this graph is called distance time graph? Because, sir, this side then distance, this side then time, distance and time putting, then distance time graph. No, that's connects. Uniform motion. Same, we're discussing about distance time graph. So same, one line will be here, one line will be here. This line will show distance, this line will show distance, and this line will show time. This side is time, this side is distance. Let's say you started working from your home and to school. Okay, and let's say I'm writing down the time here. Now home to school, you have started traveling from home to school. So what is the what is my okay, home to school, you have started traveling from home to school. Let's say the distance, total distance is, let's say, 300. The total distance is, let's say, 10 kilometer. 10 kilometer. Okay, and total time it took 30 minutes. Okay, 10 kilometer and 30 minutes. So let's say you traveled around 10 divided by 30, 10 kilometer by 30. So you traveled 1 kilometer, okay, in 3 minutes, 2 kilometer in 6 minutes, 4 kilometer in 12 minutes, 6 kilometer in 18 minutes, 8 kilometer in 24 minutes, and 10 kilometer in 30 minutes. Okay, you can see here the line, why I'm making it 6, because 5 is here, 5 is here, and it is here. Or let's say, sir, make this is very complicated, make it simple one. So let me make it simple. I'll make it very simple for you. How shall I make it simple? Okay, let's say you traveled 2 kilometer, okay, in 5 minutes, and another 2 kilometer, 4 kilometer in 10 minutes, and 6 kilometer you have traveled in 15 minutes, 8 kilometer you have traveled in 20 minutes, and 10 kilometer you have traveled in 25 minutes. Okay, you have traveled like this. Let's say, let's make it another way. Now every 2 kilometer in 5 minutes, sir, 2 kilometer is here, 5 minutes is here, so it is, make it straight line, make it like this, 1 point. Another is 4 kilometer in 10 minutes, sir, 10 having time, then 4, 10 having time, then 4, sir, another point is here, 6 kilometer you have traveled in 15 minutes, sir. Okay, 8 kilometer you have traveled in 20 minutes, sir, this one. Sir, 10 kilometer you have traveled in 25 minutes, sir. Okay, this one. Now you can join this line. Okay, you can join this line, and this line will be like this. Okay, now this is called equal distance in equal time. Look, distance to 2 kilometer, 5 minutes, another 2 kilometer, another 5 minutes, 2 4 only 2 gave, right? And here also only 5 gave. Equal distance, equal time. This is uniform motion, and this is a graph. What kind of graph? Distance time graph. Let's go another one. For non-uniform motion, how the graph will look? Sir, this is very easy. Let's say non-uniform motion means you have traveled. Look, you traveled 2 kilometer. 2 kilometer you traveled in how much? No. You have traveled in 2 minutes. Time is in second. This is time. This is distance. And in 2 seconds you have traveled around, let's say, 1 kilometer, 1 meter. And in 4 seconds you have traveled around, look this, look you how to make this is 4, right? From 4 goes straight, and this one, so you have traveled around 8 meter. And look, if you look, in 2 you have traveled around this one, in 4 you have traveled around this one, in 6 minutes, in 6 seconds you have traveled around 18 20 something, in 8 you have traveled around 30, no more than 30, it is around 32. Now look here, time, let's say, and let's say this is distance. Time is 2 4 6 8. Distance is in 2, it is, let's say, 2 meter. This is 8 meter, and this is 18 meter, and this is 32 meter. Look here, time is equal, right? Equal time, but distance is 8 and 2, sir, 6 gap between these two, sir, 6 meter gap, sir. 8 and 18, 10 meter gap. 18 and 32, sir, this is how much, sir? 14 meter gap. Look, time then equal time, but distance then not changing equally, right? Unequal distance in equal time. This is called non-uniform motion, and this is how the graph will look like. This one, you can see the green one going like this, right? You can see this. So this is your graph. Okay, let's go next. Velocity time graph. What is velocity time graph? Now if you are putting, instead of speed here, instead of distance here, you're putting velocity, then it is velocity time graph. Velocity, and this side you are putting time. Uniform velocity means, sir, velocity will not change. Sir, 30 kilometer per hour having my speed, then if my speed is 30 kilometer per hour, same speed I'm going to travel. Sir, 30 kilometer per hour having means same speed I'll travel. I'll not change my speed. Are you having, is there speed? Yes. This is uniform velocity. It is changing at same velocity. It is going at same velocity. Okay, don't look for distance time graph. If this was distance and if this was time, then this is same distance, but this time velocity is here, so same velocity. I hope you understood. If you are finding any difficulty, small difficulty, comment is there, comment section is there, it's for you. Okay, please do write in the comment below. This is velocity time graph. Velocity is not changing, same velocity, 30 kilometer per hour all the time. If velocity is not changing, same velocity, it's called uniform velocity. Second, uniform acceleration. Uniform acceleration means velocity is changing uniformly. Sir, what is that? Equal velocity, let's say 10 meter per 10 second, 5 meter per second, another 20 second, 10 meter per second. Equal velocity, changing same velocity in equal time. Okay, equal velocity in equal time, that is uniform acceleration. Okay, now one interesting thing, let's say this is velocity time graph. What is velocity? Velocity is equal to displacement by time. Okay, now I have told you, you have to take velocity and speed as same thing from now on. So can I write down velocity? Let me write down velocity as distance by time. Okay, you will understand why this is taken, but it will take time. You will understand this in class 11. Okay, why velocity? Some class 11 students also don't understand, teacher also don't understand why they are taking displacement and distance as same thing. But if you are interested, you can write in the comment below. I'll explain it, don't worry. Okay, but for now let us consider distance and displacement as distance. What is distance? Distance, I can find out distance from here. How? Sir, distance will be equal to time will come this side. So it is velocity into time. Okay. Now let's come to this graph. Let me say, okay, this is my graph. Can you see this graph? Sir, rectangle they're not having na. Actually there was not rectangle. Actually there was not rectangle. There was this straight line. Now if I find out the area under this line, then I can make a rectangle. Okay. Now what will be the area of this one? Area of this one. Understand, this is very important. What is the area of this one? Sir, area, this is rectangle. Area will be length into breadth. Sir, length how much? Length is time. Time into breadth is how much? Sir, breadth is velocity. So time into velocity is velocity into time is distance. Same here. Sir, this one then not rectangle, this is triangle, right? So let's find the area. Area, what is the area of a rectangle? What is the area of a triangle? This is right triangle, right? Area will be 1 by 2 into length into breadth, or length into height. Sir, length is what? 1 by 2 into length is time. Height is how much? Velocity. So time into, forget half. Time into velocity is distance, sir. Are you getting my point? Time into velocity is distance. So area under this, I've explained you. Area under the curve, it gives distance. Distance is given by area under this. How? Sir, area will be velocity into time. Velocity into time means distance. Okay. I hope you understood the graph. I've explained some of the basic graph. If you don't understand any graph that is given in the textbook or anywhere you find out and you didn't understand anything, okay, then I'm always there. Please, I'm requesting you, make it a comment here. Give a comment. Okay, I'll help you. Now let's go to the most important part. It's a difficult part also. Most students find this one difficult. So it may take a very good time for me, another good time solving this. But let's go step by step. Equations of motion. This is very important. You are going to discuss this. The equations of motion is not going to leave you. If you happen to study physics in higher class, I want you to study. Please do study. If anyone is watching me till here, okay, then please study. It will shape your brain. Okay. Do whatever you want to do in life. It's your choice. But at least, okay, at least study some good amount of physics. You'll enjoy, okay? You'll enjoy life. Okay, you'll enjoy nature. Let's continue, sir. Don't do too much. Waste our time. You teach, I'll teach. Okay, let's go. There are three equations of motion. One is V is equal to U plus AT. Don't worry, I'll explain. Another is A is equal to UT plus half AT square. And another one is V square is equal to U square plus 2AS. First, V is equal to U plus AT. Sir, what is V? V is final velocity. V is final velocity. Sorry. Second, U is initial velocity. Initial velocity. V is final velocity. U is initial velocity. A is acceleration. A is acceleration. T is time taken. Okay. S is displacement. Okay, now these are the units, these are the term used. Sir, V, why using final? V is velocity. U is initial velocity. A is simple, A acceleration. T time. S, sir, why S using for displacement? Why displacement is not using as D? It's physics, okay? They just want to use S, so they are using. Just remember this. This you have to learn. Now, let's go first equation. V is equal to U plus AT. V is final velocity will be equal to initial velocity plus acceleration into time. Initial velocity plus acceleration into time, that is final velocity. Let's go derive this one. What we are going to derive is V is equal to U plus AT. Okay, for deriving this, there is one graph, velocity time graph. The graph you can see here, it is velocity time graph. Okay, in this graph you can see that an object, this is time. Okay, O A B C, object has traveled, this is U, and this is D here, this is B here, and this is C here. This has traveled some distance and it has traveled some velocity also. Okay, and the velocity, it is this point, the final velocity is V. Okay, now first equation we are going to derive. So what is A? First equation, how to derive first acceleration? We know acceleration is XC A double C E, acceleration formula is, sir, acceleration formula is change in velocity divided by time. Acceleration is change in velocity divided by time. We have discussed this. Okay, we have discussed it. What is acceleration? Let me tell you again. Acceleration is change in velocity, change in speed. Pressing, speed is changing, increasing, right? Remember Scooty? So change in velocity divided by time. Acceleration is velocity, change in velocity divided by time. Sir, change in velocity means what? Sir, I am driving at 30 km/h. If I increase to 90, my velocity changes 30 to 90 km/h. Sir, velocity, how changing? Speed changing? I am telling you, velocity and speed take same now. Speed and velocity are same, distance and displacement are same from now onwards. So you are driving and your speed changes from 30 to 60, 30 to 90. So speed is changing. So how to find out how much changes, how much speed changes? Sir, final how much? 90 minus 30. So V minus U divided by time. We have discussed this. So acceleration is equal to final velocity minus initial velocity divided by time. Okay. Now from this graph, acceleration is equal to velocity. What is velocity here? DC, final velocity, minus AO divided by time is OC. What is DC? DC, final velocity, is given to be V. What is AO? U. OC, let's say T. So A is equal to V minus U divided by T. T goes this side, V minus U equal to AT. So can I write on V is equal to U transfer this side, AT plus U, or I can write on this as U plus AT. So this is my V. V is equal to U plus AT. I hope it is clear to you. A is equal to V minus U divided by T. V is equal to U plus AT. Now let's go to second equation. So what is second equation? Second equation is S is equal to UT plus half AT square. UT plus half AT square. Sir, what is S? S is displacement. Sir, what is U? U is initial velocity. Initial velocity. T is time. A is acceleration. Acceleration. T is time again. Okay. So now from the graph, I need to find out displacement. Okay. So displacement and distance are same, right? Now I've told you something. Do you remember? Have you remembered till now? I have even forgot. Let me rough this. Okay, let me explain you from this graph. I've told you something. What will be distance? Distance or displacement is equal to velocity in time. Just now I explained you, right? Velocity into time. So what will be the distance here? Sir, this one area from this one area will give, this area will give how much? What is that? Distance. I've told you just now, this area will give distance. So distance will be equal to area of this one, finish. Now what is our second equation formula? Second is S equal to UT plus half AT square. Sir, distance I need to find out, S we need to find out, right? So what is S? S means area, this one, find out area. What area? OA BC, area of this one. plus area of this one area, plus this one area, plus this two. Find out the area. So that will be your distance. So distance S will be equal to area of OACD, or area of rectangle OABC, area of triangle BCD, area of triangle OABC, area of triangle OABC. Okay, area of rectangle OABC plus area of triangle BCD, area of triangle BAD, area of triangle BAD. Okay, now what is triangle rectangle area? Area of rectangle OABC. What is the area of this one? What will be the area of this one? Sir, easy. OA into OC. OA into OC. Rectangle, right? This is rectangle. Rectangle area will be length into height, or length into breadth. Length is how much? OC. Breadth is how much? OA. OA into OC. OA is how much? OA is U. Into OC is how much? Sir, T. So can I write down this as UT? So from my equation S equal to UT plus half AT square, I got UT. Now what is the area of this one? Sir, area of this one will be, this is triangle, right? This one is, sir, this one is triangle. So triangle is half into this one AB into, sir, height, this one BD. Sir, AB how much? AB is half into AB is time. BD, sir, BD, B and D, what is BD? BD is, can I write down BD as DC minus BC? I need to find out BD. Look, what do you need to find out? I need to find out this one, BD. BD will be equal to DC minus BC. DC minus BC is BD. So area of this triangle will be AB into BD. Half into AB into BD is the area of this triangle. Now half into AB is, what is AB? AB, sir, AB is time. Into, sir, BD. BD, what is BD? Sir, BD is DC minus BC. So write down DC minus BC. Half into T into, sir, what is DC? DC means DC. Can you see DC here? This one, DC, sir, from here to here, sir, this is V. So V minus, sir, this one, BC is, what is BC? This one, BC is, sir, U. V minus U. So 1 by 2 into T into, sir, what is V minus U? AT. Sir, from where knowing? From here. V minus U, AT. V minus, from first equation. V is equal to U plus AT, right? So I need to find out V minus U. It is AT. From here. So 1 by 2 into A T into T square. So I got half AT square. Okay, now I'll explain you. Look here. I need to find out the area of rectangle OABC. Area of OABC I found UT. In area of triangle BAD I found half V minus UT. Okay. Now instead of V or V minus U, I put, instead of V minus U, I'll put substitute, or instead of V, this I'm putting equation number 1. Okay. If I put here, I'll get this equation. Have you understood? It's very easy. Okay. S is equal to UT. UT from area of rectangle plus half AT square from area of triangle plus first equation. First equation also you'll use here, right? Have you understood? Let's go next. Let's derive the third one. Third equation, derivation of third equation. So same graph we are going to use. What does third equation says? Third equation is V square is equal to U square plus 2AS. V square is equal to U square plus 2AS. Sir, this one then difficult? No. Okay. What do we need to do? You have to remember the previous one. Okay. But before doing that, we know something called area. Look here. I need to find out A second. Let me say I want to find out A second. How can I find out? I can do the area of all these things also, right? This whole thing is called trapezium. This is called trapezium. Name of this is trapezium. So what is the area of this? Area of this is, what is the area of trapezium? OA plus DC into OC. Area of trapezium OA plus DC into OC. So area of trapezium is OA plus DC into OC. Now sir, what is OA? OA is sir, O to A. It is U. OA. DC is, what is DC sir? C to D. Sir, this is V. So OA is U plus V. Sir, what is OC? OC from O to C. Sir, OC, what is this? Sir, time T. V plus U into T. Okay. If you look here, third equation derivation, S equal to U plus V into T. Okay. Now, OA plus DC into this one divided by 2, or I can write a 1 by 2. 1 by 2 will be there. This is the formula, half OA into DC into OC. Formula for trapezium. Okay. Now, if you look here, so I have derived till here. Next, from the first equation of motion, V is equal to U plus AT. From first equation, this one you know, right? V is equal to U plus AT. From here, I can find out T will be equal to, this one will go this side, V minus U. This will be AT. So T will be equal to V minus U. A will come downside. So T is equal to V minus U divided by A. Now, if I substitute this here, if I take this and substitute here, so it will be S is equal to 1 by 2 U plus V into T, which will be 1 by 2 U plus V into T. T is V minus U divided by A. So I can write down this as U plus V, V minus U divided by 2A. I'm just doing calculation. V plus U, V minus U divided by 2A. Now this is V plus U, V minus U, U plus V, or I can add in V plus U, same thing. So A plus B, A minus B, A plus B into A minus B. What is this? A plus B, A minus B. Formula is A square minus B square. Similarly, V plus U, V minus U. Formula is V square minus U square divided by 2A, divided by 2A. Finish. So after this, S is equal to V square minus U square divided by 2A. 2A will go this side. 2AS is equal to V square minus U square. I need to find out V square is equal to U square plus 2AS. This is the formula. V square is equal to U square plus 2AS. I am deriving this. Okay. So this is the third equation of motion. Are you understanding this? Are you understanding? We have discussed, we have derived three equations of motion. First, V is equal to U plus AT. From where? How did you derive this? From acceleration formula. Acceleration is change in velocity divided by time. Acceleration A is equal to V minus U divided by T. From this, I'll derive the first equation. Second equation, from where did I derive? I derived from the graph. Graph, what is the graph? Area of the area under the graph. First, I took for triangle, a rectangle, and I found out rectangle one, what is the area? UT. And for triangle, what is the area? I found out half AT square. UT plus half AT square is equal to S. Second equation. Third equation, what did I do? I didn't take area and triangle different. I took the whole trapezium formula. Okay, whole trapezium formula, I found out the area again. And I used the first equation here also, and I calculated little bit using mathematics. Mathematics also, A plus B into A minus B formula I use, A square minus B square. I use that formula and I calculate that third equation. I hope you know till here. I hope you know how to do this one. Okay, is it clear to you? Okay, if you have any doubt, anything you want to ask, comment is there. Even silly question, if it is related to the subject, you can ask any silly question. If it is not related to the question, the subject, then of no use of asking. Okay, I hope my mic is on. I hope it is working. I hope today I'll be able to upload this video. Now comes the last topic of the text. After that, I'll do all the calculations and all, whatever given, numericals and all. But let's discuss this. Uniform circular motion. What is uniform circular motion? When an object, when the velocity of an object changes, the object is said to be undergoing acceleration. The change in velocity may be due to change in. Okay. We have discussed about uniform circular motion. We're discussing that. So the magnitude of velocity, direction of motion, or both. Let's say, before discussing this, let me explain step by step. Let's say object changes its velocity. You are going in a circular, you're going round. Okay, you're changing velocity. Then you can say, okay, you are having acceleration. If your velocity is changing, then we can say you are having acceleration. Velocity can change. Sir, if I'm driving my bike, my speed is 30 km/h, but I'm going like this. I'm going circle. Sir, my velocity is changing or not? Changing. Are you getting the point? Let's say velocity means speed and direction. Velocity means speed and direction. You are traveling in a straight line. Let's say 30 km/h. You are not changing the speed. Sir, my speed changing or not? No. Velocity changing or not? No. But now let's say you started turning like this. Okay, you are going to Imphal side, but now you are turning towards my side again. You are turning like this. Now, sir, is my velocity changing? Yes. Why? Speed changing? No. 30 km/h, same speed. Okay. Sir, velocity changing? Yes. Why? Direction changes. If direction changes, okay, then velocity changes. If direction is different, velocity is different. Sir, velocity number then no changing, 30 km, then 30 km. No. Yes, 30 km, 30 km. I understand that. Speed is same. I can understand that. But direction changes. That means velocity also changes. Very interesting concept. Okay. I hope you are getting my point. If you don't change the speed, fine. But if direction changes, no, then your velocity is different. Okay. So we are talking about circular motion. Uniform circular motion. Circular motion. You are going around. Let's take for this first example. In this, let's say you started moving from A. You went to B. From B, you change the direction. You went to C. From C, you change the direction. You went to D, and from D, you change the direction. You're changing the direction all the time, right? So, a motion of athlete, a rectangular track, the athlete moves at a uniform speed. Speed is same. Speed is uniform. But direction is changing. Direction changes. Speed is uniform, but direction changes. Let's say hexagon like this. If you started traveling like this, go 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 like this. You are changing here also. You are changing direction. Here you are changing direction. Here you are changing direction. Here speed is same. Let's say, but direction you are changing all the time, right? But if you go here, you start walking here. You are changing direction here also. You are changing direction here also, here also, here also. You are changing direction at this position, right? Direction changes. So athlete changes direction. Okay. Now let's say if you take circular motion, you are changing direction every moment, right? If you are taking any circular motion, then direction changes at every moment here. Every position you are changing a direction. Okay. So as the number of side increases, the shape approaches to a circle, the change in direction becomes continuous. You are changing direction everywhere. Okay. Now this is called acceleration. Sir, speed is same. Yes, your speed is same. Speed is same. Let's say you're walking, you're running at the same speed. I understand. But if you change the direction also, then there will be acceleration. Are you getting the point? If velocity changes, what is acceleration? Acceleration means velocity will change, right? Velocity means not only magnitude, direction also, right? If direction also changes, only direction changes or speed changes, then there will be acceleration. If you change the direction also, there is acceleration. Sir, speed is same, but direction only changing, no? Then this is same velocity, uniform velocity. No, that is acceleration. Okay, so that motion is called accelerated motion. Okay, if an athlete takes time t is takes to complete one rotation cycle, or let's say one good concept here is, let's say you are taking a circle. Let me take this one, and you started moving from here a position, and you reach till a again. So what is the velocity, what is the speed, what will be the speed? Speed will be, sir, from here, if I travel from here and if I reach here, so it will be this one is called circumference, this one total length will be 2 pi r. 2 pi r. What is 2 pi r? Circumference of a circle. If this is a circle, if this is a circle, then the formula for circumference from here, if you want to go till here, this formula is 2 pi r divided by time. This is one of the formula that I'm just explaining. Okay, have you understood this? This is, if you didn't understand also fine. Okay, this is not needed, but understand, if you're changing the direction, then you are having acceleration. Understand that. Okay, fine, this much is okay. I don't want to discuss about uniform motion of the moon as uniform circular motion. So even velocity, you are changing velocity all the time. So this is uniform velocity, changing uniform motion. Why? Because uniform acceleration we can call, because you are having changing the direction all the time. Moon is going around the sun, and the moon is going around the earth. Satellites are moving around. Cyclists are moving, velodromes, rotating stones. If you are taking a stone and moving like this also, the stone is having same speed, let's say. It is changing the direction all the time. So that is having uniform motion. Why? Changing uniform velocity. Change in velocity is uniform. Uniform acceleration. Not uniform velocity. Okay. Uniform acceleration. Okay. Conclusion, even though speed is constant in uniform acceleration, uniform circular motion, velocity is not, because direction changes. So if speed can be constant but velocity is different, when it is possible? In circular motion. Okay, therefore uniform circular motion is an example of accelerated motion. So these are some solved example I'm going to discuss about. These are in textbook, I think, not written wrongly. If any mistake is there, then I have done mistake in making PPT, making these notes. Let's go with the first example. Now I'm going to discuss only numericals. Okay, how to use whatever we have learned so far. So let me summarize. What did you learn? First thing we learned about is, when do you say object is in motion? After that, what did you learn? We learned about first, when do you say object is in motion? Second, what did you learn? We learned about frame of reference. After that, we learned about what did you learn? I forgot the topic. What is that? Write down in the comment. You cannot say to me, right? Okay, let me tell you. First, we learned about different type of motion. Then we learned about frame of reference. Then we talk about motion is relativity. Okay, further, okay, for sometimes later in physics you are going to learn about special theory of relativity and all. Very interesting. Okay, don't worry. If you are interested, I'll make such videos. Don't worry, I'll make it videos and make short videos and upload. After that, we discuss about motion, distance and displacement. Then we discuss about velocity and speed. We discuss about uniform motion, non-uniform motion. Then we discuss about acceleration, uniform acceleration, non-uniform acceleration. We discuss about negative acceleration, positive acceleration. We discuss after that about three equations of motion. First is v is equal to u plus at. Second is s is equal to ut plus half at square. And third is equal to v square is equal to u square plus 2as. And we have derived all the three. We have discussed about graphs also. There are two kind of graph: velocity time graph and distance time graph. And we have discussed a different thing like at constant speed, uniform speed, non-uniform speed, and all we have discussed there. Okay. Now we are example one. Now we are discussing example number one. A dog runs 12 meter in the first 2 seconds, 18 meter in the next 4 seconds. What is the average speed? So there are two speed. A dog is there. This is my dog. And dog is running. It runs 12 meter and take 2 seconds. And after that again, this dog from after that it runs again. How much? 18 meter, and it took 4 seconds. So what is the average speed? It's nothing. First 12 meter, after the 18 meter. So find out total distance. Total distance is how much? Total distance 12 plus 18. 12 plus 18, 30 meter. Total time, how much time? 2 seconds and again 4 seconds. 2 plus 4, 6 seconds. Speed is 30 divided by 6. So it is 30 divided by 6, 535 meter per second. Finish. This is example question. Next, example 2. A car covers 225 km in 5 hours. Calculate the average speed. Average speed is distance divided by time, 225 km divided by time. But average speed in 3 km per hour, then okay, speed 225 divided by 5, it is 45 km per hour. Now, the question, this is another interesting part. Question is asking us to calculate in meter per second also. How to calculate? Let me do this. 45 km per hour. I have to convert in meter per second. How to do? 45 kilometer. In 1 kilometer, how many meter are there? Sir, 1000. 45 into 1000 divided by hour. Hour is, in 1 hour, how many seconds are there? In 1 hour, there is 60 minutes. In 1 minute, there is 60 seconds. So 1 hour will have, sir, 60 into 60 seconds. Okay. Now, if I cancel all these things, okay, 45, 0, 0 will be cancelled. This 2, 0 will be cancelled. And if I cancel 3, 2, 6, 3, 9, 4, 3, 3, 1, 3, 3, 5, 15, 2, 5, 10. Again, I can cancel 3, 2, 6, 3, 5, 15, 25 divided by 2, it is 12.5 meter per second. How to convert kilometer per hour into meter per second? Kilometer, 1 kilometer will have 1000 meter, 1000 divided by 1 hour will have 60 into 60 second. So 1000 divided by 60 into 60. Calculation is done here. I've told you why, how, all these things detailedly. Okay, let's go next. The third example is, a person covers 100 meter by going 50 meter and returning back in 20 minutes. Find the average speed and velocity. So a person covers 100 meter by 100 meter by going 100 meter by going 50 minutes. I don't understand. Going 50 meter and returning back in 20 minutes. Find the average speed. A person covers 100 meter. Okay. Now what the question is saying is, a person is there. You went 50 meter. Okay, and came back. Okay, how much he came back? He came back 50. How do I know 50? Because total distance is 100. So how can 100 be possible if it is 50-minute road? You have to reach here and came back. So 50 plus 50, so total distance is 100 meter. Displacement, how much? If he goes from here and come back here, same position, how much will be the displacement? 0. Okay, he went 50 meter, came back 50, total is 100, distance is 100, displacement is 0. Time, how much? Returning back in 20 minutes. So he went and came back in 20 minutes. So 20 minutes is the total time. Okay. Now, this is given in meter. Look. Let me explain this. This is given in meter. So this is time is given in minute. So time is given in minute. Distance is given in meter. So you convert minutes into seconds. You convert minutes into seconds. So time will be equal to 20 minutes. So why second? It is meter per second is the SI unit. Forgot that. Meter per second is the SI unit of velocity, right? So now what the question is asking? Question is asking us to find out speed and velocity. Speed is distance by time. Distance is 100 meter by time. So velocity how much? Displacement by time. Displacement how much? 0 meter. 0. Okay. 4 question. Mr. Tomba accelerated from 0 to 10 meter per second in 40 seconds. Then they accelerated to 6 meter per second in 10 seconds. Find the acceleration in both cases. Okay, we need to find out the acceleration. Let's take the first case. He accelerated from 0 to 10 meter per second. What is 0? From 0 to 10 meter. 0 is initial velocity. V is final velocity. T is time. Acceleration is velocity final minus initial divided by time. V final is 10. Initial is 0. Time is 40. 10 by 40, 0.25 meter per second square. Calculation, simple. Okay. V minus U, 10 minus 0 divided by 40, you got 0.25. Sir, from where meter per second square? I told you. SI unit of acceleration is meter per second square. How did you find out? Sir, acceleration is equal to velocity by time, and velocity is meter per second by second. So meter per second square. I've explained you. I'm explaining again and again so that it will stick to you. Let's go second case. Now second case is from 6 meter per second. He deaccelerates to 6. Now you are traveling in 10 meter per second. From 10 meter he went back to 6 meter per second. In second, from 10 meter per second. Now 10 meter per, look, from 0 vehicle was at stop, he reaches to 10 meter per second, and from 10 meter per second he applies brake and he came back to 6. Second case we are discussing, from 10 he came back to 6. So 10 is my initial, 6 is my final. Now acceleration is final minus initial divided by time. 6 minus 10 is minus 4 divided by 10 minus 0.4 meter per second square. This is y minus. Why minus? Sir, this is negative acceleration. Negative acceleration means I went from 0 to 10 meter per second. From there I apply brake. So speed decreases to 6 meter per second. It decreases, so negative acceleration, deceleration, that's why minus sign. Let's go next question. Example number 5. A car accelerates from rest to 144 km per hour in 20 seconds. Find acceleration and distance covered. Solution. So initial u is 0, v is 144 km per hour. Okay. Now look, it is rest 144 km per hour. This is speed given, right? In 20 seconds, this is second. This is kilometer per hour. So you convert kilometer per hour into meter per second. Okay, so convert this. Kilometer per hour, you convert into meter per second. Kilometer per hour is 144 kilometer per hour. So 144 kilometer per hour. Okay, now you convert this 144 kilometer per hour. We have to convert into meter per second. Why? Because it is given in second, this one. So convert 144 into kilometer is 1000, hour is 60 into 60, 0 0 cancel, 0 0 cancel, 2 5 10, 2 3 6, 2 3 6, 2 7 14, 2 2 the 4, 3 3 2 the 6, 3 4 the 12, 3 8 the 24, 8 5 is 40. Okay, you can just cancel and calculate, you get 40. So from 40 on this one I converted into meter per second. Time is already given as 20 seconds. Now what the question is asking, find acceleration. Acceleration is v minus u divided by t. Okay, easy. Sir, now another is distance covered. Distance covered, there are two formula for distance covered. Second formula, let's go to second. S equal to ut plus half at square. From this, okay, do we know u? Do you know u? Sir, I know u because car starts from rest. Starting, u is starting speed, right? So car was starting from rest, so u is 0. Okay, u is 0. Next, sir, t, time is given 20 seconds. Okay, what else? Half a is acceleration. Sir, I found out acceleration, calculated here, just now calculating. And t square, time square. So time is 20, 20 square is 20 square. So look, u is 0, 0 into t it is 0, plus half a is 2, t square is 20 square. So I got half into 2 into 20 square, 2 cancel, 20 into 20 is 40, 400 meter, using second formula. Okay, this is another example. Let's go one more example. Then there are 3 more examples. Sorry, okay, it's taking quite long, but anyway, I'm just explaining. A car accelerates from 36 kilometer per hour to 144 kilometer per hour. You are driving vehicle, and from 36 kilometer your vehicle is speeding and reaching 144 kilometer per hour. Time is 20 seconds. Find acceleration. Simple. U given, V given, U is initial one, convert into 36 kilometer per hour, convert into meter per second. How to convert? 1000 divided by 3600, or 1000 divided by 60 into 60. You can write on anything and convert. Okay, and here also converted, V converted, U converted, time is 20 seconds. Acceleration formula is V minus U divided by T. Acceleration formula, I hope now you got bahar this one. So V is 10, V is 40 meter per second, U is 10 meter per second, and if you divide, you get 1.5 meter per second square. My voice is changing, and it's already nearly 2 hours. Okay, I'm just teaching. Okay, if anyone is looking till here, thank you so much for studying. Okay, you'll do really great in life. I'm telling you, you'll do really great in life. Now, A is given, S is equal to UT plus half AT square. S is equal to UT, U is given, T is given, 1 by 2, A is calculated, T square, T is there 20 seconds, you square that. So if you do that, U is 10, T is 20, half, A is 1.5, T is 1.5, 1.5, A, T is how much? 20, 20 square. 20 square is 400. Okay, 20 square is 400. And if you multiply this, 10 into 20 is 200. And 200 you can cancel like this. You can cancel this one. This 10 into 200, you'll get 200 into 10. 20 into 10 is 200. This one, it is 200 into 1.5. 200 into 1.5, it is 300. Multiply, you'll get 500 meter. It's easy. Okay, let's go next. A police van with acceleration minus 7 meter per second square takes 5 seconds to stop. Find the initial and velocity and the distance. So velocity, acceleration is given. Okay, time is given. So final and vehicle stops. So you are applying the brake and vehicle stops. So final velocity is 0. Now we need to find out the initial one, U we need to find out. So use V is equal to U plus AT, first equation. So V is 0, A is given, T is given. From first equation, V is equal to U plus AT, U given, U I need to find out, U I found out. Second, I need to find out distance, S equal to UT plus half AT square, use this formula. S UT plus half AT square. U I found out, T plus half, A is given, T is given. Use that and find out. Simple. Let's go next. A car accelerates, accelerates minus deaccelerates means applies brake. So and stops. So stops in 3 seconds. If vehicle stops, then final velocity is 0. You're applying brake, right? So final velocity will be 0. So from V is equal to U. I'm explaining faster because video is getting too long. Okay, I didn't think so anyone is watching till here also. If anyone is watching, thank you so much. I'm telling you again and again. V is equal to U plus AT. Use this formula and you'll get U. And use formula S equal to UT plus half AT square. So S is a UT plus half AT square. T is 3, square is 9. So you find out S. Similar like previous one. Okay. So let's go to exercise question. Exercise question says a boy drives to school at 15 km per hour and returns at 25 km per hour. Find the average speed. So what does a person do? Let me do this question differently. A person travels a distance and he drives to school at 15 km per hour. Speed is given 15 km per hour and returns at 25 km per hour. Okay, and find the average speed. Okay, average speed is nothing but if it goes at 15 km per hour and returns at 25 km per hour, I need to find out the average speed. So how to do? So this question has very different way of doing. What to do is first find out the time taken to reach the school and came back. Okay, so time will be distance by speed. You know speed formula, right? Or let's use speed formula. Speed is equal to distance by time. Speed is given 15 is equal to distance by time is drive to school and returns. Find the average speed. Time is not given. Okay, so time of, so time to school is, if I take time, this will come this side, 15 will go this side, distance by 15. So time is d by 15. Time to return, time to school, time when going to school, and returning time, distance divided by speed. Okay, formula is this one: speed is equal to distance by time, time is equal to distance by speed. Use this formula, you got another. Now what is the total time? Total time is d by 15 d by 25. This is the total time taken. Okay, why am I calculating total time taken? I'll tell you. So if I calculate 15 d by 15 plus d by 25, and if I calculate, I'll take LCM 25, 15, 25, not LCM will not be 25. I'm calculating d by 15 plus d by 25. LCM for these two, if you know how to find out LCM, LCM will be 75. 15, 5 is 75, plus 25, 3 is 75. 5d plus 3d is 8d by 75. I'm doing faster, okay? I just want to make it by 2 hours, okay? Otherwise, student will not watch after looking the time, okay? If it takes too much time. So 8d by 75. So this is the total time. Now what is the average speed? Average speed is total distance. Total distance is 2d. Going one side, this is total, this is distance going time, and coming time distance is d. So d plus d, 2d, divided by total time is 8d by 75. So if I calculate, 75 will go upside, dd cancel, you'll get 18.75. Okay, don't do like this. 25 plus 15 divided by 2, how much this one will be? 5 sir, 10, 2 plus 1 3, and then 4, do, sir, it is 20. Wrong. Okay, you cannot do like, you cannot plus speed and divide by 2. Most student does this and it is wrong. You have to find out the average speed. Average speed formula is total distance by total time. Total distance find out, total time you find out. Average speed is total distance divided by total time. Okay, next question. A motorboat accelerates at 2 meter per second square for 10 seconds from rest. Find distance. Now this is acceleration. A is from rest. Remember this rest, okay, rest means u initially 0. Okay, from rest, starting from rest, u will be 0. So u will be 0. So a motorboat accelerates, A is 2.0, u is 0, and from rest. So what is the distance? So distance is equal to, sir, how to find out? Formula A is equal to ut plus half at square. U given, t given, A given. Use formula, find out second equation. So how do you know how to find out? If they are asking distance and if they are giving acceleration. If distance is given and acceleration is given, then you can use the equation. If distance is given, asking distance and have to find out acceleration, then most probably you are going to use equation, either first or second. A car at 72 km per hour deaccelerates at 5 meter per second square. Find the time to stop and distance. Okay, find the time to stop and distance. So I need to find out time and distance. U is given, and after that v is given. Deaccelerate, okay, no, this is the vehicle stops. U is given, and vehicle's time to stop, vehicle stops, so v is 0. Acceleration is 5 meter per second square, but negative acceleration because you are applying the brake. Now use the formula v is equal to u plus at, then you can find out t. From now, time you can easily find out like this. Distance you can find out by using s equal to u plus half at square. Can I use this? Sir, do I know u? Do I know u? Yes, sir, u I know. T I know. Sir, t also I know. Ut plus half a. A I know. Sir, yes, I know. T square, yes, I can use t square. Or I can use this another formula. So s equal to v square minus u square divided by 2a. V square I know, u square I know, a I know. I can use this also. You can use any formula and find out. Okay, you can use both the equations and find out. So try by a equal to ut plus half at square, you'll get the equation or not. Let me do a equal to ut plus half at square. Look, they are using another formula. I'm going using another. U is how much? 72. Time is how much? What is time? So time is 4 seconds plus half. A is how much? Minus 5. Time is how much? 4 square. 72 into 4 plus into minus is minus 5. 4 4 16. 65 into 16 divided by 2. 2 8 16. 72 into 4 minus 8 5 40. Am I doing any mistakes? Sorry, not 72. This is not 72. Sorry, this is 20. 20. 20. 20 into 4 is 80 minus 40. 80 minus 40 is 40. I got the same answer. You can use the third equation or you can use the second equation. Okay, both you can use to find out S. Okay, you know second and first equation which I'm talking about, right? There are three equations of motion. You can use second and third, anyone to use this to calculate this. Question number 4, from the distance time graph, C is traveling fastest. Which graph is that? Okay, they are talking about graph and I don't have the graph. Sorry. Okay, I think there are another two questions are there. Question number 4 and 5. I think question number 4 and 5 are talking about graphs. And sorry, that video also, I think it already reached 2 hours. So I don't want to continue further. And there are two questions, and in this PDF I've given, you can look the answer. You can see the answer here. Okay, question number 4 answer is here. Question number 5 answer is here. I may be wrong here. Check, verify. If you are watching till here, then please do. And please make sure. So if you have anyone has watched till now, I don't know if anyone is reaching here. If anyone mistakenly have reached till here, thank you so much. And please do like, share and subscribe also. Okay. Now let me summarize the chapter, whole chapter. Let me summarize. So we have started talking about motion. There are different kinds of motion. After talking about motion, we discuss about frame of reference. After that, we discuss about relativity. Motion is relative. You are sitting in a bus and driver is there and your friend is standing outside. There are trees. We discuss about this. After that, we discuss about distance and displacement. We discuss about velocity and scalar and vector quantity. Scalar means only magnitude and vector means magnitude and direction. Then we discuss about velocity and speed. We discuss about motion, uniform motion and uniform motion. Then we discuss about acceleration. We discuss about different type of acceleration, uniform acceleration and uniform, positive, negative. And we discuss about different kinds of graphs. We have derived 3 equations of motions. After that, we have calculated, we have discussed about circular motion also. We have calculated, we have done example questions, we have done all the exercise question. The whole chapter is complete here. Okay, this is the summary. So, okay, we have discussed everything. I hope you understood. Thank you so much. See you again in another video. Thank you.